eye's optical axis. So for any optical system, we need to figure out what is the optical axis of the system. First, let's talk about the optical axis itself. An optical axis is a conceptual line that's running through the center of points of any optical objects like a camera, lens, microscope, or telescope. So for example, in this system, we can see that it's completely rotationally symmetric. And this axis is the optical axis because all the objects that we have is rotationally symmetric. Even the ray can pass rotationally. So that one, we call it the optical axis of this system. In some systems, we don't have a true rotational symmetric axis, like, the system that you have astigmatism. But for that optical system also, you have two plane of symmetries. So the coincidence line of these two plane of symmetries is your optical axis. But the problem is that for all man-made optical systems, like, like this lens, which is a man-made things, is completely rotationally symmetric. But for natural things like our eye, it's not completely rotationally symmetric. So what should we do? For this system, this optical system, because it's completely rotationally symmetric, we can imagine a line that passing through all the lenses, all the optical elements that we have that are rotationally symmetric, and we call it optical axis. But for the eye, it looks like symmetric. It's like circular, but when you look at it with more details, you can see that it's not completely rotationally symmetric. So what should we do for that optical system, which is, in this case, is our eye? So for the eye, as I mentioned, it's not rotationally symmetric. We need to figure out how we can find the optical axis of this system. So for this system, because it's not rotationally symmetric, we introduce several axes. It's not just one axis. So that's the reason that for the eye, the optical system is very complicated. We have a lot of axes, different axes, that if it was just completely circular symmetric, we only use one axis and we call it optical axis. But as I mentioned, it's not rotational symmetric, so we have different axes. But what is the optical axis of the eye? But for any optical system, we need to define something as an optical axis. So for the eye, it's not rotational symmetric, and there is no true optical axis that passes through the center of all optical elements that we have. So for that reason, we just put the best fit. The best fit that roughly passes through the center of non-symmetric objects, off-center things. That one, we call it the optical axis of the eye. So there is no real optical axis for the eye, but the best fit that passes through roughly all the centers of the objects that we have in our eye, we call it the optical axis of the eye. Thank you very much. And here are some references that I used.